Hello, 607 and 608. Today's learning target is I can represent a three-dimensional figure using a net. So thus far, we have been working with 3D figures. We were working with rectangular prisms, and we were finding the volume of them. So now we're going to continue working with some 3D figures, but we're moving on from volume. So solid figures, also called three-dimensional figures, are figures that have a length, a width, and a height, as in 1, 2, 3 different dimensions, three-dimensional figures. They can be classified by the number of faces, edges, and vertices that they have. A face is a flat surface of a solid figure. So far we've worked with rectangular prisms. It's a 3D figure, but the flat surfaces of the prism were all rectangles. An edge is a line segment where two faces of a solid figure meet. So where those two rectangles come together and form that corner, that's considered an edge. A vertex is the point where three or more edges of a solid figure meet. The plural of vertex is vertices. So if you think like the corner of a shoebox, that would be the vertex. A prism is a three-dimensional figure with a pair of parallel faces called bases that are congruent, which means equal in math, polygons. Polygon means shape. Its other faces are rectangles or parallelograms. The table below, which we're going to look at in a few moments, shows some common prisms and their nets. The other type of 3D figure we're going to start to look at is called a pyramid. A pyramid only has one base. So kind of if you think of like social studies in Egypt, the bottom is a flat shape, and then surrounding the base are triangles. So a net is a two-dimensional representation of a 3D figure. The purpose of a net is that it can be folded to make the 3D figure. You can use the nets to find surface area. That's what we will eventually use our nets for. A net has the same number of faces that the 3D figure, the solid figure, has. So right here is a net of a cube. I know it kind of just looks like a weird X or sideways T, but if we were able to fold it up, we would be able to create a cube. Not all nets can be folded into a 3D figure. You have to check to see if it could be folded together to create that figure. So this one is crossed out because there's no way for us to try and fold this up to make a solid, as in no openings anywhere, figure. This one can be folded to create a rectangular prism. This middle row would have to kind of like circle up, and then either side would close up the box. This would be a square pyramid where the square in the middle would stay as the bottom, the base, and the triangles would fold up around it to create that pyramid. This side couldn't possibly wrap around this circle, but then these two sides, one is curved, one is straight, would never meet together to form an enclosed figure. All right, so let's try and visualize this. This is a hard idea to understand, especially when we can't be in the classroom together, where typically Miss Maljevic and I would actually have you cut out nets and make the figures from them. Unfortunately, the world had other plans, so we can't do that with you guys. But this shows you a simulation. If I drag this arrow down here along, you'll see this is a rectangular prism unfolding to create the net. So as we unfold it down the middle, we see the 4 rectangles, and then on either side there is a 5th and a 6th rectangular face that would enclose the box. Here's a rectangular pyramid. As I unfold this, you see that there's a rectangle in the middle. Remember, a square is a special type of rectangle. You would only know it was a square based on measurements. So I have the rectangle in the middle there, and the triangles, it's a little clearer down here with the darker lines, the triangles surrounding the sides of it. Here is a triangular pyramid. The difference between a triangular pyramid and a rectangular pyramid is simply that that base figure, as you see as I'm unfolding it, that base figure is a triangle and not a rectangle. And the last shape that we'll work with is a triangular prism. So remember, a prism has two bases on either side. So for this rectangle, the two bases were rectangles and then a line of rectangles down the middle. A triangular prism will still have that line of rectangles down the middle. However, on either side, the bases are triangles. So now instead of having 4 rectangles down the middle to connect it like we had in the rectangular prism, we only have 3 because these side bases are triangles which only have 3 sides. So you're only going to need 3 rectangles down the middle to connect it. This link is available in the Google form for you to mess around with if it will help you to see the nets better. You do not have to worry about a cylinder or a cone. You don't visit those shapes until the 7th and 8th grade.